All right, we are doing Chapter 5, Test Review. We're going to review by using Chapter Test B. It's very similar to Chapter Test A, though, which is what we will be taking on Monday. All right, so 1 through 4 on Chapter Test B says, solve the system of linear equations by graphing. Now, when you're solving a system of linear equations by graphing, all you got to do is graph the two lines and go find where they meet. Okay? So, number 1, you guys tell me, where do I start with graphing this first equation? Start at 3, very good, because 3 is the y-intercept. Okay, so let's go ahead and put a dot at 3. Do I go up 3 or right 3? Up 3, because it's the y-intercept. What is the slope of that first? 1 over 1, which means I can go up 1 over 1, or I can go, very good. Now, I like to extend these for as long as I possibly can because you never know where the next line might hit that one. So I'm going to draw my little line through here. Bear with me, it's not going to be very pretty. Now, what is the starting point of the next graph? Very good, -3. Now, where does that point go? On the x? Which axis, x or y? It's called the y-intercept for a reason, right? It means it crosses at the y-axis. So I'm going to go down 3. Now what's the slope? Good. The slope is -1 over 1. That means I'm going to go down 1 to the right 1, right? Or I could go up 1, back 1, up 1, back 1, up 1, back 1. Do you guys see where they meet? So what is, very good, -3, 0, though, okay? That would be your solution. So on the test, this is going to be 2 points. 1 point is, did you graph them correctly? Are your lines not going like, some of you guys had your lines going like opposite directions completely, it was crazy. So are your lines graphed correctly? That's 1 point. Did you give me where they cross? That's the next point, okay? Sound good? Now, this one was super easy because they were both in y equals mx plus b. Sometimes they're not going to be in y equals, well, sorry, this one is. But how about, this last one is not. Let's do one more where they are in y equals mx plus b, and then we'll do the one where they're not, okay? Okay, how about number 2? Where would I start for graphing this first line?
2.
Very good. 2 is the y-intercept. So let's go put a dot at 2. What is the slope? Up 1 over 3. So I go up 1, 1, 2, 3. Or I can go down 1, back 3. All right, I'm going to draw my line. Now, where do I start with my second equation? Very good. Now, does that mean I go down 3 on the y or I go back 3 on the x? Very good. Down 3 on the y. What's the slope? That means what? I could go down 2, back 1, or I could go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Do you see where they cross? What is the point? 3, 3. Very good. How do you guys feel about 1 and 2? If this was on your test, could you do it? Right, so that means you need to tell me, why do you draw blank? Like, when you get there, is it not knowing where to start?
I think it's just because it's a test. It's like, that's how it's always.
You have like that test anxiety, and everything just goes away. Well, hopefully on Monday when we take this test, there's only going to be the 4 of you, so there shouldn't be too much anxiety of just knowing that you can like sit, take the test. I allow you guys to use your notes on all the quizzes, but yet do you guys still feel that way when you get to the quiz even? You just still draw blank? So notes probably won't help the anxiety, right?
Like, no matter how many times I would go through my notes. Then I look through my notes and I'm like, oh god.
What about studying? Do you guys study at all?
Yeah, I watch your videos.
Watch the video. You know what I would do to study for this test? I would go, when I'm watching this video that I'm recording right now, I would pause when you get to the test A and the test B as I'm flipping through them. That's not cheating. I'm doing it on purpose for you. Pause the video, and that way you're not surprised when you get the test on Monday. You can be like, oh, okay, I saw that I tried this one on my own, you know? So definitely try to do that. Also, watch this video again. Look at your notes again, okay? All right, so let's try 4. 4 is not in y equals mx plus b, but it's super easy to get it there. I want it to look like this. How do I get y all by itself on that side of the equation? Okay, very good. We're going to get that x on the other side first. We can't deal with what's directly happening to y yet, right? We have to get that extra stuff gone. So now I've got 3y equals 6 minus x. Very good. Now here's the part that people forget, okay? You ready for this? What number is next to my x? A 1. It's hidden, but it's there. Now if I divide this by 3, I have to divide everything by 3, okay? Now, if you don't put that 1 next to your x, a lot of kids think that now that's negative 3x, but it's not, right? It's negative 1 divided by 3. 3 over 3 is gone, so now we're just left with a y. What is 6 divided by 3? 2? Now, look at this. This is where some people panic and go, oh, yuck, that's a fraction. But guys, what is slope supposed to be in?
Fraction.
So do I need to panic, or do I literally just take that and go pop it in over here? Yeah, let's do it. This is going to be 2 minus 1/3 x. Anything next to your x is the slope, right? Sweet. No panic. All we really had to do is just move the x over and divide everything by 3. Okay? Before we graph that, let's try it for the next one, the next equation. How do I get y all by itself? Very good. Got to get that 4x out of there. You're super close. Not divide by 6, divide by... Very good. I have to take that negative with my 6, or else I have that negative with my y, and then I'm dividing everything again. So take that negative with your negative 6, okay? So divide by negative 6, divide by negative 6, divide by negative 6. Okay, what is negative 6 over negative 6? So that's bye-bye, y. What is 6 divided by negative 6?
Wait.
That's okay, we can go back.
Like, put on your negative 6. Oh, wait, never mind. Oh, wait.
Okay, so we're right here, right, Addie? We just divided everything by negative 6.
Yeah, but when you do it to the opposite, when you add.
We're multiplying right here, right?
Yeah.
The opposite of multiplication is division, and you just take what you actually have and divide it. You don't do opposites like that way. You do opposites if you're adding and subtracting, but we're dividing. Make sense? Okay, so what's negative 6 over negative 6? Yeah, it's 1, so it's gone, right? So now we're left with just y equals 6 divided by negative 6. Negative 1. Very good. Now, once again, negative 4 divided by negative 6, don't panic. That's our slope. However, here's where you do need to be very, very careful. What's negative over a negative? A positive. So our slope is actually plus 4/6x. Okay? How do you guys feel about that? Do okay getting y by itself? I feel like you guys did a good job getting y by itself. Now that we have y by itself, I have these 2 new equations that I can go graph, but here's where you have to be super, super careful. You guys are super smart, and I'm not worried about you. Some people, though, they look at y equals mx plus b, and now they get their b's and their x's all confused because these two are not in the right spots, right? But I'm not worried about you guys because you're super smart. You can tell anything next to the x is the slope, okay? So, on my first equation, the red one, where is my y-intercept? It's the 2! Very good. Which means I'm going to go ahead and put a dot on my 2 on the y-axis. What is my slope? Okay. You guys, I'm really happy that you all focused in on that negative sign, right? Slope can either be negative 1 over 3 or it can be 1 over negative 3. Agreed? Which means I can go down 1 over 3, or I can go up 1, back 3. How do you guys feel about that? Good? All right, you tell me. How do I graph the next line? Start at negative 1. Good job. That's our y-intercept. Now what? Up 4 over 6. Now, looking at my graph, do I even have enough lines to go 4 and 6s? Why? I mean, obviously, look, it stops at 3 on all ends, right? What do you know about 4, 6? Can that be reduced?
Yes.
What would I reduce that to?
2/3.
2/3? So would you say the slope of 2/3 is the same thing as the slope of 4, 6?
Yeah.
Sure. Can I do the slope of 2/3 and actually fit on this graph?
Yeah.
Let's do it. So I'm going to go up 2 over 3. Boom. Right away. Do I find out where they cross?
Yep.
Very good. 3, 1. Do you guys follow me okay?
Yep.
Those do have a lot of steps to them, especially when you have to change them into a y equals mx plus b formation. Do you see how like chaotic it really does look with all my work everywhere? Like as we were doing it, it wasn't so chaotic, but when you look at it, it's like, whoa, you get overwhelmed, right? I highly suggest you do this extra junk on a separate sheet of paper so that you're not overwhelmed with this tiny little space of just stuff everywhere, okay? Okay. All right, let's move on. 5, 6, and 7 says solve the system of linear equations by substitution. Substitution is fun, you guys. You just have to make sure you have at least one equation that has a variable by itself. Okay? Let's look at number 5. I'm going to insert one of my blank little boxes right here so that we can have some workspace. Okay, you ready? I know, I pretty much did. All right. When I substitute, I have to have at least one equation that has a variable by itself. Do I have that with these two? Yes, in fact, I've got 2 equations. Kind of nice. When I substitute, I'm saying the equal sign is the word is, right? This is saying y is x plus 3. Doesn't that mean I could plug x plus 3 in for y on the next equation? So you tell me, what is my new giant equation?
X plus 3 equals 4x minus 6.
Got it. Now, to solve for x, I need to get x all by itself. Right now, I've got x's on both sides of my equations. If you have x's on both sides of your equations, what do you need to do?
Subtract x.
We need to get x together, and you're going to subtract it? I like that idea the best. You guys see how he said that? Do you see why he said that? Okay, we're going to get x's all together. X minus x is gone. I'm left with 3 equals, what is 4x minus x?
3x.
3x minus 6? Okay, how do I get x all by itself?
Wouldn't you subtract 6?
Well, okay, we never do what's directly happening to the variable yet, right? We save that for last, which means we have to get the extra stuff around it gone first.
Plus 6.
Oh.
This is a subtract 6, correct? So the opposite of subtract 6 would be 2. So we're going to add 6 to both sides. What is 6 plus 3?
9.
9 equals 3x.
Oh, so now you divide.
Now you divide. What does x equal?
3.
Okay, now we're not done. Our final answer has to be an ordered pair, just like up above, right? Which of the 2 did I just find, x or y?
X.
So I'm going to plug in a 3 for x. Now, here's where you have your final step. You take what you just found and go pop it in at the top equation, okay? But you have to pop it in for the correct variable. I saw some people on the quiz last time taking x equals 3 and putting it in for y. You don't want to do that. You just found x. How easy is this one? What is 3 plus 3?
6.
So what does y equal?
6.
6. Ta-da! That's it. Not so bad, right?
Oh.
Okay, want to do number 6?
C.
Okay. Let me erase all my extra work. All right, you ready? Do I have at least one equation with a variable by itself?
Yeah.
That's great. That's all we need, right? I'm going to start with that equation. It's the bottom one this time, okay? It's saying y equals or is this. So who can I go pop that in for?
Top 3.
For y? Very good. What's my new equation look like?
X plus 2x plus 4 equals 7.
That was good. I have a question. This is hypothetical because it's not actually like this. But what if this was instead of a plus, what if this was a minus?
What would you have to do parentheses?
Woohoo! Yeah, you got to do parentheses. You got this. If this was a minus, isn't that actually negative 1y?
Yes.
Which means isn't this whole thing getting multiplied by negative 1y?
Yes.
Which means my equation would look like this. X minus 1 parenthesis 2x plus 4. And then I would have to distribute that negative 1 through to everything. Now that's only if what? If it was a minus y. Does that make sense? But, like I said, that's hypothetical, because is that our situation right now? No. Okay, so now what do I do? I've got this nice long equation.
Variables.
Variables! What do you want to do with them?
Well, 2x plus.
Well, they're together, so you can just add them.
Yes, they are the exact same thing. They're the same term. So I can just say x plus 2x is
3x
3x.
plus 4 equals 7.
Okay. How do I get x all by itself?
Wouldn't you
Spencer, I gotta have your eyes on the board, okay?
subtract 4?
Yes, very good. Why did she say subtract 4 and not divide by 3?
Because you have to give x 3 now.
Yes. If anything's directly snuggled up to x, we do that last, right? Okay, so these are gone. 3x equals, what is 7 minus 4?
3.
3?
Now divide by 3.
Now divide by 3. In my ordered pair, who did I just find?
X.
How do I go find y?
Now you go plug x in
Now, which equation should I do it for?
top equation.
We can do it for the top equation. Doesn't matter.
No.
I always like to put it into the top equation, but honestly, looking at the bottom equation, if I plug in a 1 for x, isn't that a very easy problem to solve?
Yeah.
What's 2 times 1? 2. What's 2 plus 4?
6.
Yeah, wasn't that so much easier than putting it right here and then subtracting a 1 from each side and all that good stuff? I mean, they're both pretty easy.
Probably would have forgotten to do that part anyway.
You've got to remember to get your final
There's
coordinate.
so many steps.
I know.
Why is it math easy? Just have series.
What is y equal?
6.
Very good. Wow, they were really nice to you guys on 5, 6, and 7 because every single one of them, they gave you an equation that had y by itself at least once, right? If they wouldn't have, and let's say both equations looked like this, what would you have done?
You would have. Don't you have to keep.
Sure. Does it have to be y? Could it be x? Sure. You just have to get a variable by itself.
Add the 3 over to the 12.
Wouldn't you want
The 3y?
Yeah.
Sure.
You would move it over.
And then you would have x equals negative 12 minus or plus 3y.
Yeah.
That would be great. And then you could plug in this for x down here.
Yeah.
Definitely. Now, they were super kind to you. I'm going to go take a little sneak back at your actual test and see if they're equally as kind. Okay? Let me see. That's elimination. Here's substitution. Look at that. 5, 6, and 7 on the actual test. They gave you each an equation, at least one equation that had a variable by itself. That's very nice. So no worries. Okay? All right. How do you guys feel about substitution? It is a lot of steps, right? So here, write this in your notebook right now. Ready? Let me erase my page and I'll tell you what to write.
I'm not as good at the one
I feel like
The elimination? We'll do elimination next.
Prepares you just for the test.
Huh?
Not, like when are we gonna use this? Like I know we probably will because MX Quickly is like really common.
Right.
But like when are we gonna use it? 'Cause I feel
In
like,
real life?
Yeah.
Well, it depends on what your job is. If you're a stock market person, if you're doing anything with money, business, I mean anything with money, you're going to use this. If you don't do anything with money, like my job, for example, I'm not a business owner, so I don't have to worry about profits and all those things, but I am a teacher, so I have to know it. But let's just say like I'm a 3rd grade teacher and I don't have to know it. Then the only time I ever had to know this was to get through high school and college. So I understand your frustration of like,
But like I know we have to use this because
Yeah.
my dad and stuff uses it all the time.
yeah,
But I just feel like school just prepares us just for the test, like in any subject.
yeah.
And I don't know if we're ever gonna use it again.
Like, what's the point in music?
Guys, you're wasting so much time on this recording by talking right now. Okay, let's keep going. Write this down right now. I like what Addie said. Addie said, it's easy. There's just so many steps, right? I'm going to give you steps right now so that you can remember, what do I do first? What do I do second? What do I do third? Okay, ready? Substitution, write this down. Oh my gosh, why am I blanking how to spell substitution? If I spelled this wrong, please don't make fun of me. Substitution. Step number 1. Have at least one equation with a variable well, I cannot spell today. I am so awful. Okay. Have at least one equation with a variable by itself. Write that down, write that down, write that down, write that down. Write that down. Spencer, write that down. Now, sometimes they give that to you, correct? Which means number 2. Let's say you've done it, you've got a variable by itself. What do you do next? You substitute, right? Whatever variable you have, you substitute that in for the next equation. So then we're going to say substitute, sub in. After you subbed in, you'll have a new equation, right? Spencer, you're writing this down? You have that whole thing right there? I don't think so. Number 3. We've got our whole equation, right? My only job now is to solve for the variable. Usually we're solving for x. Sometimes it's y though. So we'll say solve. Solve for the variable. After you've solved for the variable, what do you need to do to end it? Substitute it back in to go find the other variable, right? Very good, Spencer. Does variable have 2 R's?
No.
I've been having a hard time with that.
Bathroom, I gotta go.
Really fast, you may. I know. All 4 steps of those, that's all you have to do for substitution, okay? One equation with a variable by itself, subs it in, you'll get a new equation. Solve for that variable. Once you have that variable, plug it back into the original equation to go find the last variable. Okay? Okay, I'm going to go ahead and erase this. All right, ready to keep going? Now, I'm not so sure how many story problems I want you guys to have to do on the actual test, because I think some of them are important, while other ones I'm just kind of like, well, I'd rather you guys be able to do the basics of it, right?
Maybe 2. Story problems are not my favorite.
I know, story problems are nobody's favorite, especially,
And the way they word things just...
this,
40 watermelons.
but guys, look at number 10. This one actually isn't so bad. They're saying the measure of angle 1 is 30 degrees. Less than twice the measure of angle 2. Ooh, this one isn't very much fun.
What?
English?
Okay, so they didn't say it's 30 degrees. I didn't read it all the way. Measure of angle 1 is 30 degrees less than twice the measure of angle 2. What is the measure of angle 1?
I always have to break these kind of problems up. Like,
Oh, I do too.
and butcher them.
I have to butcher them too.
Angle 1, you just take...
Angle 1 equals 30 minus
Divide by 2.
2 times angle 2.
So you
Okay,
divide
so
the angle 2
you do
by 2
100,
and then subtract
you
it
do
by 3.
180
180.
minus...
We don't know though. We don't know. Is it going to be 180
Yeah.
minus whatever we get for angle 1?
180
24.
180 divided by 3, wouldn't it?
Let me check your actual test and see what we got going on, because I don't want to waste our time too much on these.
So 180 divided by 3, then divide that by 3.
180 divided by 3?
Yeah. Because you have your 2. You have, like, you know?
180 divided by 3 would get you 3 perfectly same angles, right?
Yeah, I know. And then you divide those.
No.
Yeah.
You don't know. I don't excited.
That's okay. I'd rather us not waste our time on one of these problems and go do elimination. You guys okay with that?
But then you would like find the two of those angles. You would add them together and then subtract 30 from one of them.
Here's what you have to do on this one. You have to make two equations just like what we just did up here and do substitution.
That's gonna draw a picture.
You would have to have two equations. Your first equation would say angle 1 equals 30 minus
I think I could do it. I think I could do
2
it.
times
I
angle 2.
can. I'll do it.
Addie, don't waste our time. Let's go on to the two elimination. That's the stuff what we just did freshly, right?
So we know things are problems.
I don't think so. I think I would rather test you on can you actually do the basics of this rather than can you apply it to like these harder word problems. If you can do the basics, then I feel comfortable with you going on to math next year, okay? That's what I care about. Okay, so let's do elimination. This is the one we just freshly learned this week. Now, when you eliminate something, it means you are getting rid of it. Now, we've learned there are two methods to getting rid of something. I can either add or I can subtract. But sometimes will adding and subtracting not work? Yeah, and then that's when we have to use multiplication to help us out. Okay? You focusing, Addie? Focus, focus, focus. I know it's hard. I know, but you gotta focus on this on the board. Okay, I've got 3x minus y equals 2. And I've got 2x minus y equals 3. If I add or subtract, can I get rid of a variable?
Yes.
What do you want to do, Max? You want to get rid of the y's? What could I do to get rid of the y's?
Plus, yeah, plus 1.
You want to add everything? Okay, so if I add everything, here's what's going to happen. You watching, Spencer?
No, you would subtract because then the 1 would bring it to be a positive.
Okay, so Addie's already seeing that this isn't going to work. What is 3x plus 2x?
5.
What is negative y plus negative y? Signs are the same, so we just add. It'd be negative 2y, right? And already you guys can tell this isn't going to work because I didn't eliminate anything. So Max is right. We do need to eliminate the y, but how can I get rid of it? Not by adding, but by... So let's subtract everything, okay? What is 3x minus 2x? 1x. What is negative y minus negative y? So if I rewrite it, it looks like this.
Nothing.
Negative y minus negative y, you're saying that that's like a plus?
Yeah.
Which is 0, nothing.
Negative 1y plus 1y equals 0.
Very good. And so that makes it go away. But now I still have the 2 and the 3. What is 2 minus 3? Negative 1. So it's going to be x equals? How easy was that? We found our first doodad. Boop, boop. Negative 1. Now how do I go find my y? Plug it into my top equation? Sure. Let me pop that in there. X equals negative 1. Who am I plugging it in for? X. What is 3 times negative 1? Anything times a negative, just one negative, will always be a negative. Think of this. I got two negatives, right? When I multiply them or divide them, they will always equal a positive. Just picture those two negative signs making a plus sign, okay? But if there's only one negative sign, he can't make a plus sign with anybody. So he's always going to stay negative. Yep. So what's 3 times negative 1? Negative 3. Negative 3 minus y equals 2. Subtract 3? If I subtract 3, will those cancel out? Yeah, I have to get rid of it by doing the opposite of what it is. It is negative 3. The opposite would be to do a positive 3. Okay? Am I losing you guys? Are you there? Okay. That's away. So it's negative y equals 5. Am I done? Why? Very good. You cannot leave your variable negative. That's actually negative 1 like Addie just said. How do I get rid of that negative 1? Very good. Y equals what?
Negative 5.
Negative 5. So what is my final?
Negative 5.
Yep, and that's it. Okay? Let's talk about the steps. Remember we just talked about the steps for substitution? Here's the steps for elimination. First, find out if I'm going to be adding or subtracting. If neither one work, maybe you got to multiply. Okay? After you find out what you need to do, take that sign like we did with our subtraction. We took the subtraction sign and we gave it to every single term in the problem. And then you just solve. It's super easy. You want to eliminate one variable. Okay? And then just like substitution, when we're done, we just take what we got and plug it back in so we can go get the other guy. We found y. Okay? Okay, let's do another one. You guys really walk me through this one, okay? Elimination. What do you want to do?
No, we gotta get the two. Oh, we got your two back.
Right,
Ooh, Max, I like what you said. What were you saying?
You need to multiply.
Why does he know right away we need to multiply?
Because there's two on the top above the x and the two on the bottom below the y.
Yeah. If our variables don't have the same term next to them, nothing's going to just subtract nicely, agreed? We have to have something that has the same. Max, what do you want to do? Do you want to multiply the top row by 2 or the bottom row by 2?
Bottom.
Okay, so let's multiply everything by 2. Here's where kids get messed up. You have to distribute to everything. What I suggest doing is rewriting this first equation. I'm going to rewrite it down here. 2x minus y equals negative 2. Now I'm going to distribute and rewrite my next equation. What is 2 times x?
2x.
What is 2 times negative 2y? Negative 4y. What is 2 times negative 16?
Negative 33.
32? Okay. Now what? You want to do subtraction? I think so. Max is going to get rid of the x's, right? And if I added them, I'd get 4 x's. I want no x's. So we're going to subtract everything. What is 2x minus 2x? Gone. What is negative y minus negative 4y?
3y.
Okay, so you're saying this is the same as negative y plus 4y? When you subtract them, 4 minus 1 is 3. Sign of the bigger number is 4. So yes, you're right. It is 3y. I'm going to go ahead and erase this stuff so we have some space. So this is 3y. What is negative 2 minus negative 32? Careful. It looks like this.
No, subtract.
Good. It's negative 2. I feel like Spencer and Addie are not looking at the board. Negative 2 minus negative 32.
Oh, okay. Let's just be 30.
Yeah, that's a plus sign. So it's negative 2 plus 32. 30. You're subtracting them, right? Yeah. So it's going to be 30. Signs are different, so we subtract. Divide by 3? Y equals 10. Here's how this one's a little different than what we've done before. Which of my coordinates did I just find? You know how many kids are going to put a 10 right here out of habit? Don't do that. We just found y. Okay? Now, go plug y equals 10 in. Now, here's the other thing kids are going to do. They're going to plug y equals 10 up here. That's not our equations anymore, guys. Those are like garbage. Those are trash. We don't use those anymore. We have to plug it in for the new equation we've created.
I totally would have done it.
Yeah, once you have created something brand new with multiplication, you have to plug it back into your new equations, okay? Okay, so now let's do it. It's going to be, here I'll grab a new color. It's going to be 2x minus 10 equals negative 2. How do I solve for x?
So you have to subtract 10.
If I subtract 10, I get negative 10 minus 10.
Plus 10.
Okay, plus 10?
Yeah.
Plus 10.
Yeah. 8.
8. Very good. Signs are different, so we subtract.
And divide by 3.
X equals what?
4.
Woo! So my final answer is 4, comma 10. Okay. Now, here's the last thing I do want to go over with you. The lesson that you learned yesterday on my video. Yesterday you learned that sometimes Sometimes there are no solutions.
Yes. Okay.
And sometimes there's an infinite amount of solutions. But then we get lucky sometimes when we just have one
I
solution.
feel like I got those two answers way too much.
On 8,
Yeah,
I
I do.
got no solution, and I wanted to. I got.
We can check the homework in a second. Let's finish with this little review video first, and then we'll check the homework, okay? Now, without graphing, which means we're going to have to either use substitution or elimination. Without graphing, determine whether the system of linear equations would have one solution, infinite solutions, or no solutions. Okay? Let's do this. Just by looking at this first one,
Solution.
what would you like to do? Would you like to substitute or eliminate?
Eliminate.
Substitute.
Here's what I'm thinking. If I did elimination, there's nothing very, very nice that I could eliminate, right? Do you notice how this is in y equals mx plus b? Were any of our elimination equations up here in y equals mx plus b? No, which makes it really hard to want to eliminate anything, right? So what could I do instead? Substitution. Ready, Addie? You're going to walk me through this one.
Yay.
You are. How do I substitute for these two equations?
You get one equation that has a variable by itself.
Got it. Check off that first step. Now what?
Substitute the equation.
Okay, so this is saying y is this. So could I go plug that in for y down here?
We have y equals x or parentheses 11. No, I don't know.
Okay, I'm taking this whole chunk and just pop it in there for y.
So it'd be
Oh,
11x
why?
plus 8 equals 9x minus 7.
11x plus 8 equals 9x minus 7. How do I solve for x? Yeah, the x's are all separated by an equal sign, so how do I get them on one side?
Subtract 11x.
Okay, we can subtract 11x. Let's do that. Spencer? No, thank you. What is 9 minus 11? Signs are different. Yep, so we subtract.
Negative.
Negative 2?
3.
9, 10, 11?
Oh, yeah.
Negative 2. Why is it negative, not positive?
Sign the bigger number.
Sign in the bigger number. Good job. And a small number minus a big number, obviously, is going to be a negative number, right? Okay, now what?
Add 7.
Boom! Bye-bye. What is 8 plus 7?
15.
Negative 2x. Now what?
Divide by 2.
Divide by what?
Negative 2.
Thank you.
Oh, sorry.
Yeah, this one will probably be into a half, right? So what plus what would get you 15? 7 and 7 is 14. 7.5 plus 7.5 would be 15. So that means 15 divided by 2 is 7.5. But, it's 15 divided by negative 2. Negative 7.5. Now, in my ordered pair, who did I just find?
Your x.
My x. How do I go find my y? Plug that little sucker in. I'm going to plug that in for x. What is 11 times 7.5? Here, we can do it real fast. 5 times 1 is 5. 5 times 1 is 5. Placeholder 0. 7 times 1 is 7. 7 times 1 is 7. Add them all up. Over 1. Over 1. 82.5. Okay, so I've got 82. Oops, 82.5 plus 8. Okay, what's 82.5 plus 8? 90.5?
Yes.
Woofda. What is this final y?
1.5.
Yeah, yuck. Yuck. But the whole point was there a solution?
Yes.
Yes. So I would say on number 14, I'd say one solution. And the solution was negative 7.5 comma 90.5.
Yes.
Okay. Let's keep going. How about 15? Okay, let's do that.
I don't know, something like myself.
I think we should get the x by itself. I was thinking y at first, but now that you said x by itself, I like that better. Because I feel like that'd be so much easier. If I wanted to get this x by itself, what do?
You would subtract the 6.
From both sides? So this is going to be 14y minus 6 equals x. Now can I substitute this chunk in for x? Okay, so now I've got 28y equals 2
2 plus 12.
Is it what?
I don't know.
You have to divide by. Oh wait, just kidding.
You guys were not paying attention.
Not fine.
You weren't paying attention. This is x.
Oh,
I'm putting x in for here.
14y minus 6.
No, isn't it for parentheses?
Yes, why is it parenthesis?
Because it's being a bunch of twos.
Yes, if it's being multiplied, it means I got to multiply that 2 by everything that x is, right? So it's going to be 2 parenthesis,
14y minus 6.
parenthesis. Don't forget the plus 12. Okay? Distribute.
Yes.
What is 2 times 14y?
21.
What is 2 times negative 6?
Negative 12. Or negative 12.
Negative 12. Okay, something good's about to happen.
So the
The
12's
12's X each other out.
Okay, those are bye-bye.
20y equals 28y.
Or equal 1.
Divide by 20.
Y equals 1.
Anything divided, so.
Y equals 1. Right?
What?
Infinite solution.
Does that mean that they will land on top of each other? Or does that mean there's no solutions?
Infinite.
Yes. Is y the same as y?
Yes.
If it said y equals x, we'd have an issue. Because y is not x. Y is y. Is y y? Sure. I don't care what that means, actually. But what I know is that if I were to graph that, they would land exactly on top of each other. So number 15 is
Infinite.
infinite solution. We're almost there. Last one.
Oh, even a space for 16.
That's because my box in the way. This looks like a good one for substitution.
Yeah.
Want to do substitution? Plug that in for
Y.
y. What's my new equation?
15x plus 1 equals 15x plus 2.
Isn't it just going to be...
Okay, and then you gotta get x on one side.
It's going to be no solution.
Why?
Because you have different spots, but everything's the same. So you're just going to be like...
Yep. And if you look, my x's are now gone. I'm left with 1 equals 2. Is 1 2?
No.
No, it's...
No. So no solution for 16. Okay. I'm going to go and stop the video, but I want you guys to get this out of this lesson. You need to watch this. You need to study. You need to go back in your book and find out what you got confused on. You have to learn how to study for math, okay?
Okay.
Okay. Test on Monday. You got this?
Yep.
Okay.